right, guys, at the time of this filming, it is 4th of July weekend. So to celebrate, I am going to keep a promise that I said I would give you, especially some of you guys in other countries who didn't have access to this content. And that is the videos that I produced for Autel for their scan tool, so that owners of the scan tool can access videos right there on the scan tool to walk through if they have a certain check engine light code or symptoms or whatever, and they can kind of walk through the videos step by step on the scan tool. And as part of the agreement, I'm not really supposed to show the content, but it's been well over a year, and the problem is there's a lot of people in other countries who were not able to access that content, or maybe some of you guys just didn't want to go over to the Autel site and find it. But what I'm going to do here is show all the videos that I have made to date for Autel. These are going to be little 4-minute videos, so they're not going to be very thorough. They're not going to explain every theory and operation, but it just shows you the steps, and there's some really good case studies. And being 4 minutes long, basically this would be kind of the format that if Scotty Kilmer actually knew how to diagnose a car, this is kind of the way the videos would look. So I hope you enjoy it. If you need more Schrodinger's box, don't forget we also have my paid channel content with the really good stuff on it. That's over at www.schrodingersboxqm.com. Don't forget you can also get Schrodinger's box merchandise. I just added a new hat, by the way. And if you haven't yet, you can go over to the Autel Accufix website. You can sign up over there and you can see any new content that I produce in the future. And there's some other source out there. I don't even remember what it is, but whatever the case, enjoy these videos. These will just be back to back to back to back to back sequential 4-minute videos that I've done, so hopefully you enjoy them all. Hi, this is Matt from the Schrodinger's Box YouTube channel with another Autel Accufix case study. Working on a 2001 Toyota Land Cruiser with a V8. We've got a couple problems on this one. In this video, we are going to address a check engine light with a P0500 code. That would be a vehicle speed sensor A code. To diagnose this code, I first jacked up the vehicle so all 4 wheels are off the ground. All right, what I'm going to do is put the vehicle into drive. Just needs to go a few miles an hour here. Going to hit the gas pedal. We can see that we do have speedometer activity here. However, if we go to our live data and choose our vehicle speed, we will see, let's go into drive again, we get no RPM showing from the vehicle computer. So the explanation for that data is there are actually 2 speed sensors on this vehicle, not too unusual actually. One of them is a 3-wire Hall effect sensor located way at the very end of the transmission output. And that one is responsible for the speedometer signal. And as you can see, that's not our concern. Our concern is with the 2-wire inductive sensor, which is located in the middle of the transmission. When the vehicle's in gear, this will create a sine wave from AC voltage directly from the sensor, and we are going to back probe the red and green wires, and we're going to use a scope to look at the trace and see if the sensor is putting out a signal. If we look on the scope, we can see the sensor is absolutely putting out a very nice signal. This is appropriate. It will also be proportionate to speed. Speeding up, we can see we increase frequency and amplitude. Because the vehicle speed sensor is producing a signal and we don't see it showing on the vehicle speed on our Autel MS909 scan tool, this brings into question, is the signal reaching the vehicle PCM? So what I've done is dug out the vehicle PCM. On this vehicle we have 5 different connectors for the PCM. From the left, 1, 2, 3, the third connector will have about 9 wires in it. There will be a solid green and a solid red wire. Those are the wires for the vehicle speed sensor A. I've back probed those wires and connected those to the scope the same way I just did from the vehicle speed sensor itself. All right, let's start the car and let's put it in gear and let's read what's going into the computer. We can see it is exactly the same signal as what we have from the sensor itself. We know we are getting signal to the computer. Let's just verify that as we increase vehicle speed, we see the amplitude and frequency change. It does. Signal is absolutely getting to that computer. Because we know that we're getting speed sensor signal input into the computer and we are not getting an output data, there is no other explanation. There is a fault with the vehicle computer. This is one of the extremely rare situations where the vehicle computer needs to be replaced. Hi, this is Matt from the Schrodinger's Box YouTube channel with another Autel Accufix case study. This is a 2001 Toyota Land Cruiser. The complaint from the owner is the vehicle seems to lack power. It also has poor acceleration, kind of stumbles or hesitates under throttle, and seems to get poor fuel economy. There are no check engine lights on. All right, we're going to pull trouble codes just to see if anything's pending. They have a P0500 speed sensor code. We're working on that for another video here, but already took care of that. So there are not and were not any engine-related codes on here. So we are going to get out of here. We're going to go to live data. I am going to pull some fuel trim data, long and short-term fuel trims. We can see, looking at the total trim, that is adding the short and long term for each bank together. We're pretty close to zero, so we're looking really good. Now, the complaint from the customer was when you hit the gas pedal, that's when you start having problems. Let's see if we see evidence of that. And oh yeah, we do. When we hit the gas pedal, we see we greatly increase fuel trims. Looks like long term already has balanced out there on both banks at about 21. 25 would set a code, so that's why we don't have check engine light for it, but that's pretty dramatic. We can also graph this. We're going to see all these increase with engine speed. All right, pretty easy diagnosis here. Anytime you see the increase in fuel trims as you increase engine speed, it's almost invariably one of two possibilities. Either you have a fuel delivery issue, weak fuel pump, restriction in the fuel lines, something like that, or you have a dirty mass airflow sensor. Obviously, we're going to start off with the easiest thing. The mass airflow sensor on this vehicle is extremely easy to get to. Let's take a look at it. Mass airflow sensor is right here on the snorkel. Just going to disconnect it and take a look. So if we look real carefully, we can see that the mass airflow sensor resistor is covered in quite a bit of soot and some debris. Be advised that there's also on this particular model an IAT sensor on the right over here. Be aware also that on most Toyotas you'll have another wire inside this tube here as well. Hopefully this works. If it doesn't, then we will have to do some fuel pressure testing. I also commonly use brake cleaner for this. While it's not advised, it supposedly leaves a residue. I've never had any issues. It's about a third the price of this mass airflow sensor cleaner, actually. And that's starting to look a lot more clean. Very gentle and careful. You can also use a Q-tip soaked with the solvent. The dirt insulates the resistor, so it prevents it from accurately measuring the airflow. The airflow cools down this resistor, and of course if it's insulated it doesn't cool down proportionately to the flow. Let it dry completely and then we'll reinstall in the vehicle and check our fuel trim. Okay, restarting the engine, we see we're the same as before, but again what we're looking for is a change, especially in the short-term fuel trims. They should go negative if this fixed our problem. And we can see the short terms are going very negative here. That's pulling down our long trim, and that is fixing this problem. Look at our long trims now down below 10 on bank 2 now. Let's look at that on our graph. It's half of what it was before. That's a decent fix. This is Matt again from the Schrodinger's Box Do-It-Yourself Advanced Automotive Diagnostics YouTube channel with another Autel Accufix case study. Today we're working on a 2010 GMC Terrain with an interesting complaint. The customer states that the vehicle continues to try cranking even after the engine starts. This vehicle has key start, but it has auto start technology, and clearly it is unable to recognize that the engine is running. Let's see if we can reproduce the symptoms. Long crank time, the engine has started, it's still continuing to crank, and it's stumbling and it died. Looks like we had a check engine light during that time, so let's use the Autel MS909 and pull some codes. All right, if we look at our trouble codes, we actually have two of them, a mass airflow sensor, circuit low, and what is clearly our issue, an intake camshaft position sensor, circuit bank 1. The fact that it says circuit bank 1 means this is almost guaranteed to be an electrical issue, either bad sensor or wiring, most likely not a mechanical issue. I also believe most likely the 0102 is a result of the 0340 because the engine runs really, really poorly with this condition while trying to start. We have the car running right now, which means we can get some data from it. All right, if we go to live data, and probably a CMP actuator may have what we want. That's what I want right there, our exhaust and intake camshaft position sensor counts. And if we look right here, we can see we've got no activity. We're stuck at 60 for whatever reason on the intake camshaft position counter for bank 1. So as suspected, we are not getting signal, it appears, from that camshaft position sensor. We need to check if we've got a bad camshaft position sensor or if we have some type of wiring or PCM problem. All right, so here is our intake bank 1 camshaft position sensor. We have a tan, dark blue, and orange, so let's follow those along. So our orange is going to be the signal, 5-volt reference on the blue, and a ground on the tan. All right, I'm going to hook up my scope to 2 of the 3 wires on the Hall effect sensor. We're hooked up to the ground wire and the signal wire, just the ground and the signal wire right now. All right, here's the trick. You're wondering, well, what about the reference? Well, I'm actually testing it. As we can see, we have 5 volts showing here, but we have no square wave. The fact that we have 5 volts shows that we must have 5-volt reference and ground. So the only thing that we're missing here is the signal because we are connected into the signal. This way we only have to run 1 channel on the scope. This is very easy. There is no question about it. Since we are measuring from the sensor, we have 5-volt reference, we have ground. This sensor is not producing a signal. This is going to be a bad sensor, and we will replace it. Okay, now we've replaced the sensor. We have connected up our scope exactly as before. Let's see if the car starts this time. All right, we can hear the car starts immediately right up, and check it out. We have our square wave indicating that the new sensor has fixed the problem. We can also look at the scan tool to confirm this. All right, if we go to our live data under CMP actuator, we can find those camshaft counts. And there's our counters. We see right there, we have reactivated our counter for the camshaft position sensor. This car is fixed. Hi, this is Matt again from the Schrodinger's Box Do-It-Yourself Auto Repair YouTube channel with another Autel Accufix Quick Fix. 2020 BMW X2. The issue with this car is the rear brakes are squealing. Many newer models like this, especially on luxury cars, also will have an indicator on the dashboard indicating that brake pads need to be replaced. There's an electronic sensor in the pads in some of these vehicles. On this model and a lot of new models, you're going to run into something that you may not expect, and you're going to need your Autel MS909 to get you out of trouble because it has an electronic parking brake. And in order for you to depress the piston back into the bore to make room for your new pads on your caliper, you are going to have to command through the computer for that electronic caliper to release, and you can do it with your Autel MS909. So we'll show you how easy this is to do. So this is straightforward, of course, just removing your brake caliper here. This model has a little retention clip you have to remove. We're going to resurface the rotor on this. One kind of nice thing about these models here is that you can actually usually remove the rotor without taking off the caliper support just like that. The caliper bracket can stay on. So it looks pretty basic. We want to depress this piston back into its bore, and we see we cannot do it. It's not going to press back in. The other thing is it's not that screw-in type like you often see on Volkswagens and things. The issue is back here. We have this electric parking brake system where we have to do one of two things. Either we have to actually remove this and then dial it back in so that we would be able to push our piston into the bore, or we would just simply be able to use our Autel MS909 to command this to open, which will also on some models pull the piston into the bore, but on other models, I believe this one will be the case. We have to push it into the bore, but we will have the access to do it because we've released the parking brake mechanism. So let's get to the Autel MS909. Okay, we've got the ignition on, but car not running, and while this loads, there's many ways that you may have to access this for many different vehicles. For this particular BMW, we're going to go to Service, Chassis and Suspension. We see the parking brake module here, Workshop mode. Shows we've got communication with the module, and it shows you what you would use this for. We can see one of them, replacement of brake pad. Let's continue. And we see we have two choices here. One of them is to activate the installation position, and then after replacing the pads, we will have to deactivate the installation position. So we'll access this program twice ultimately. We right now want to do the installation position. We're going to hit continue. We need to make sure that we've got parking brake released. We actually already have parking brake released, so I'm going to hit continue. It's another indication that it takes about 5 seconds. I'm going to put the microphone to the motor, and you can hear it. All right, after it finishes, we're going to hit continue. It's confirmed that it's set to the installation position. Now we're going to be able to easily compress that back in, just like that. We'd be able to do this on the other side as well. With our new brake pads installed, it's time to use the Autel to put our parking brake back in position. Navigating back to this screen as before, we're going to deactivate the installation position and continue. We need to apply the parking brake. We see the indicator has turned red. Now we're going to release it. Continue, and our installation is complete. This is Matt from the Schrodinger's Box YouTube channel with another Autel Accufix case study on a 2000 Ford Explorer with 4-liter. Owner states that they have a very, very intermittent rough idle and cutting out during acceleration. There's no check engine light. Owner replaced spark plugs, but it did not help the issue. So I used the record feature from the MS909 during a test drive. Now I did happen to catch what I believe is the issue during a wide open throttle acceleration, and we'll show you that frame right now. A wide open throttle event right here. So here we've got wide open throttle. Oxygen sensors should go rich during the wide open throttle. We can see that the bank 1 sensor lagged behind pretty bad during this particular episode. And as we go along to another wide open throttle event, we can see that the oxygen sensors behave normally this time. However, at the end of the frame, the sensor did drop out for a second there during the wide open throttle event. Given that, we only have 3 possibilities. One of them would be there really actually is a leaner condition on that particular bank causing the oxygen sensor to not be able to reach full rich. The other possibility would be bad oxygen sensor, of course, and another possibility would be a wiring problem or a PCM problem. That is the least likely because there still is signal above bias voltage from that oxygen sensor. We are getting signal from the oxygen sensor to the PCM because we can see it on the scan tool. Most likely this is either some fault on that bank causing the issue or a bad oxygen sensor. We need to get some more data. As you can see, all we have is P1000, probably from the customer removing the battery when he replaced the plugs. That's all we have. Because we're expecting oxygen sensor problem, we're just going to go with the bank 1 and bank 2 front oxygen sensor voltages. With the engine idling, we can see the oxygen sensors are oscillating normal. I am not particularly crazy about the absolute 0, even though it didn't show us a problem at wide open throttle. We're not worried about anything like a fuel pump, mass airflow sensor, because we only saw failure on one bank during the wide open throttle. So it is almost certainly an issue with the oxygen sensor. We're going to test its performance. Putting some propane directly into the air box. All right, we can see that the O2 sensors responded rich, but again, we have the blip Because we replicated the oxygen sensor dropout under a controlled condition this time, we know that this is an oxygen sensor failure. Also, because the bank 1 oxygen sensor seems to be out of its normal range, I'm going to replace both oxygen sensors in the vehicle, and then we will repeat and make sure that we've got better drivability and no more dropouts. All right, after changing the O2 sensors, first thing we notice, the idle is considerably more stable. We also see that our voltage ranges stay within spec now on our oxygen sensors, both of them, nothing going to dead zero. So let's go ahead and drive the car and see if we get any dropouts during wide open throttle this time. After test driving the vehicle several times at wide open throttle, we had no issues whatsoever. Here is a long frame here with wide open throttle. O2 sensors stay totally together throughout the entire frame. Much better responsiveness. This car is fixed. Hi, this is Matt from the Schrodinger's Box Automotive Do-It-Yourself YouTube channel with another Autel Accufix case study. Today we've got this 2014 Infiniti QX60. Pulling the code on our Autel MS909, we can see that we have verified the code, and we also have a clue about where to start. Well, the clue is on the heater part there, as well as the Bank 2 air fuel sensor. This car has an air fuel sensor as opposed to an oxygen sensor, but the heater circuits are exactly the same. And most likely we're going to find an open in the heater circuit in that actual sensor itself. But we want to do our due diligence to make absolutely sure. Right here's our connector for this air fuel sensor. If we look very carefully, we've got 4 wires. Once again, when you have the 2 same colored wires, whether they're white, whether they're black, whether they're brown, I've seen sometimes, the 2 same colored wires will be the heater circuit. So what we're going to do is disconnect, and we're going to go to the computer harness side, and we are going to look and see if there is voltage there. Now, the wires may not match colors on the computer side of the harness as they do on the sensor side of the harness. It's the sensor side of the harness that will usually have those 2 same colored wires. We could do this with a test light. We could do this a number of ways, actually, but what I'm going to do is just use DVOM here. Okay, with the engine running, we see we absolutely have voltage to our sensor. This is great news. This is going to be an easy repair, almost guaranteed. We've got an issue with the sensor itself, so let's check there. Now going to turn my meter over to a continuity measurement. All right, testing our same colored wires here. We want to just barely touch these terminals here. We don't want to spread them apart and cause a connection issue. And I expect we should see, usually you see about 3.5 ohms or so. And it's still reading out of limit. It's not unusual that you may sometimes see that you have your reading here, but if you tap on the sensor, you lose it. And that's because when these heater circuits fail, sometimes that filament, it's like a light bulb filament inside that sensor. Sometimes it makes contact still, even though it's broken just a little bit. So you might see a little bit of reading sometimes. Right now we're seeing just out of limit. Because we're reading out of limit, that means there is an open on the heater circuit in this air fuel sensor. We need to replace the air fuel sensor. Okay, we've got air fuel sensor replaced. I'm going to show you 2 ways that we could check it. Sometimes you can do this an easier way. The first way is like we did before. We're testing on the sensor side. Get 1 lead in there. Now we should see continuity. And we absolutely do. What do we read? 3.6 ohms. That's perfect. There's another way we could measure this too, and that is I'm going to connect my sensor and we're going to use an amp probe. We're going to isolate out one of the same colored wires and we're going to loop a amp probe around there and set it to the 20 amp setting. I'm expecting to see 1 amp of current if this air fuel sensor heater is working. Oh, and very interesting. I will admit I got caught off guard on this. This is actually a pulse width modulated signal here. Normally you'll just see a straight 1 amp across the board. This one is pulse width modulated. Let's get a little more detail on there, but just the fact that we see the square wave signal confirms that we have amperage, we have a repair. All right, seeing that we have a square wave pattern here with the amperage confirms that we not only have computer control to this circuit, but we also do have amperage through it. This car is fixed. We just need to reset the check engine light. Hi, this is Matt with the Schrodinger's Box YouTube channel presenting another Autel Accufix Quick Fix. This is a 97 Ford Explorer with 4-liter engine. The complaint from the owner is that only when it's really cold outside and the vehicle has been sitting overnight, they have a very hard time getting the car to start. It will crank, but it will run briefly and die. Eventually it will keep running, but very rough. But then after a few minutes that they can keep it running, it will smooth out and run perfectly fine as long as it's warm. Well, obviously there are many variables that could cause this issue. We can see we have a plastic upper intake manifold. On any vehicle with a plastic intake manifold on an aluminum cylinder head, you've got dissimilar materials, and over time what happens is the changes in contraction and expansion of those materials causes a gasket failure, which creates a rather significant intake leak, but only when the engine is very cold. Once the engine warms up, things expand. That expansion seals the intake leak while the engine is warm, and there are essentially no symptoms. This issue only happens when the engine is bone cold in open loop mode, so you can't rely on your oxygen sensor data and fuel trim analysis. So the strategy is to, as quickly as possible, get the engine to temperature and look for any residual evidence of a vacuum leak. If we find any evidence of a vacuum leak, this is more evidence that we're on the right path with a potential intake manifold gasket failure. Now, there's no check engine light on this vehicle, but we're going to start off with a fault scan just to see if we get any possible lean condition pending codes. We can see we have no codes in the powertrain. We're going to go ahead and grab fuel trim data. And even with the key on, engine off, we have our first clue. We can see that while cold, the engine is starting off with short-term trim just under 25. Let's go ahead and start this engine. You can see the engine is doing very poorly right now, and the engine just died, reproducing the symptom. All right, pushing on the gas pedal dramatically improves performance, again indicative of a vacuum leak. So we're just going to keep our foot on the pedal until the engine runs on its own. All right, now that we got the engine running on its own, we can see as we're warming up, fuel trims are fairly high. We also can verify this is a vacuum leak by pressing the accelerator pedal. We'll see our fuel trims decrease. Okay, pretty clear evidence. That is vacuum leak. We suspect that this issue is an intake manifold leak. This more than justifies us spending the time to smoke test the intake. Using a smoke machine, we are able to see there is a substantial amount of smoke coming from the upper plenum. You can also see there's a leak pretty substantial on the other side of the engine as well. This bank actually quite a bit worse than the other one. Now, I do want to point out from a procedural standpoint that I'm really just trying to show the data set that would support the actual issue we found with this vehicle in real life, so to speak. Given the symptoms that this only happens when the engine is cold, improves dramatically after the engine warms up, the fact that I can keep the engine running when it's performing poorly by having my foot halfway on the accelerator pedal, and the fact that there's a plastic intake manifold. To be honest, I wouldn't even bother with the scan tool in a real-life application. I would preserve the cold state of the engine, go right to the smoke test as my first step, but I did want to show you the data set that you would expect with this particular issue. Hi, I'm Matt from the Schrodinger's Box YouTube channel with an Autel Accufix case study. We're working on a 2000 Firebird with a manual transmission, and it has a no start. It will not even crank at all. However, all the lights and everything come on. Battery seems fine. Seems to be some issue getting power to the starter motor. So let's reproduce the symptom. Everything comes on, foot to the floor. Can you hear the fuel pump there maybe? Turn the key. Nothing happens. All right, we're going to go to Diagnostics, going to pull up my vehicle. While I do that, my strategy is going to be to pull up as much as I possibly can. And we're just going to pull up all the data that we can that will be relevant to our problem. So let's go to live data, engine live data, and let's go to data 1. All right, older vehicle here, so we may be limited in our PIDs, but I'm looking for anything that's going to be related with a no crank, and that's going to be things like starter relay information, ignition switch position information. On your vehicle, you may have a lot more than I'll have to work with. Right now, these would all be running. FC relay is going to be fan control. There's clutch switch. We're going to take that. That would definitely do it. And that looks like on this particular vehicle all we've got to go with, so that's just fine. Let's go ahead and show that. We can see the clutch is released right now. I'm going to go ahead and push the pedal in. Pushing and releasing the clutch pedal, you can see it stays released. Obviously, we see our issue. We've got a problem with this clutch switch. Let's go ahead and remove it and bench test it. Well, our Autel saved us from having to climb under the dash and disconnect connectors, do voltage checks and continuity checks with the switch, so we know we've got pretty good direction here. One thing very important, on this particular vehicle, as are many others, there are two switches connected to the clutch. This is the clutch safety switch that we were testing that we believe is not working. This is what it looks like. There is also, on many vehicles, including this one, another switch with a button on it. That button defaults to being pressed. That is going to be the clutch input switch. That gives data to the PCM, letting it know the clutch pedal has been depressed and it can adjust fuel delivery accordingly. So make sure you don't mix up your switches. This switch for this vehicle is the clutch safety switch. This is normally in an open position like it is now, and when you push the pedal, it will push in. So make sure you've got the right switch so you don't get a misdiagnosis. We're going to take our meter, we're going to set it to a continuity. Okay, we've got two terminals here, doesn't matter which one because this switch just makes connection between these terminals to continue the circuit on, so absolutely no difference, just make sure your leads don't touch like that. All right, making sure my leads aren't touching, I'm going to push the button. We can see there is no activity at all. That switch is broken, so we need a new clutch switch. When I push the pedal down now, we can see that it is depressed. That means the car should start. Let's go ahead and give that a try. There it is. Hi, this is Matt again from the Schrodinger's Box Do-It-Yourself Automotive Repair YouTube channel with another Autel Accufix Quick Fix. Today we've got a 2006 Honda Civic that has a very obvious misfire problem. We've got flashing check engine light. All right, we're going to go to the Autel MS909 here to get some data. We've got two misfires, it looks like, actually, although it feels like one. But we've got random misfire because of the two misfires detected. Anytime more than one cylinder misfire is detected, you're going to get the random P0300 misfire. Let's go to live data and look at the actual live misfire counts. All right, so we can see on our misfire counts that we actually seem to have identical misfire counts on cylinders number 1 and 3. One thing, if you had a waste spark system on a car with this type of symptom and data, you would strongly suspect a bad waste spark coil. A waste spark coil is going to be one coil that shares with two cylinders. We do not have that set up here. What we're going to do is make this very friendly for do-it-yourselfers that won't have a lot of fancy electrical equipment or know-how. And what we're going to do is just a cylinder drop test. Just to unplug a coil here, we're going to start with number 4 because we know that should be good. And we see the engine reacts immediately. So we know that that coil is working and that that cylinder is working. We know there is spark from that coil. Almost killed the engine there. So we know that coil is good and contributing. Let's try number 3. This is one that was giving our misfires. And same thing. It is clearly contributing spark, for sure. Now, we still may have misfire for other reasons, but spark does not appear to be one of them. Let's go to number 2. Again, the engine absolutely does not like that. Now let's go to number 1. And there it is. When we unplug number 1, we see there's absolutely no change, no reaction. So we know that we either have no spark here or we have some other misfire problem The misfires are detected by the crankshaft position sensor, and changes in speed with the crankshaft position sensor are how the PCM determines a misfire has happened, and that sometimes can be a little bit faulty and falsely attribute misfires from perceived lower crankshaft speed on a different cylinder. What I'm going to do is just take a simple test light, going to connect it up to ground, touch it to positive to make sure that our connections are good. We're going to look for spark here. There is no spark jumping to that test light. This is definitely a coil problem. Now the question is this a bad coil, or do we not have signal to the connector? For do-it-yourselfer, really easy way to do this, we can just take one of the known good coils, like number 4, plug it in there, see if this behavior changes. And look at that. We have spark. What does that tell us? We know that our connections for the coil are good. That's a bad coil, no doubt about it. All right, we're going to install the new coil. And immediately the engine absolutely runs perfectly. All right, there's our misfire data, and we see no more misfires. The only movement is our misfire cycle counter, but no misfires on any of the cylinder. Cylinder number 3 was a false alarm, and that is definitely something you need to keep an eye out for, even if you have a single cylinder misfire. As you see, you can absolutely get false misfire detected from a single cylinder misfire. Thanks for watching. I hope you found this helpful. Hi, this is Matt again from the Schrodinger's Box Do-It-Yourself Automotive Repair YouTube channel with another Autel Accufix Quick Fix. This is a 2006 Honda Civic. It has a ABS light on. Some check engine codes can cause the ABS light to light up because the PCM doesn't feel confident in controlling things like engine speed and things, so it will disable ABS. We did earlier do a repair on this car for a misfire. That can very often cause ABS light. However, that is repaired. This ABS light is absolutely a standalone fault. If you have any other things like check engine faults, you're going to want to diagnose those first and repair them before blaming an ABS. We want to get our Autel MS909 scan tool and get some data. All right, we're going to go to the control unit, ABS, and we're going to go to trouble codes, and we can see we've got an 1119 right front wheel speed sensor malfunction. Not very specific, but that's okay. All right, we're going to go to live data, and we can see our left and right, front and rear wheel speeds can be shown here. So what we're going to do is go to a good wheel. Let's go to the left front. And I'm just going to turn this wheel by hand. We do get a reading for that wheel speed sensor. We're now going to rotate the front right, and we can see there is no signal reported to the scan tool from the wheel speed sensor, so we confirm we have an issue. So what we're going to do is disconnect the wheel speed sensor. We're going to set up DVOM on a 20-volt scale here. We're going to go to our connector side for the ABS module. We can see it as a 2-wire sensor, so that's going to be an inductive sensor as opposed to a Hall effect. So we're going to look for a bias voltage here. Should be about 5 volts. And there it is. So that's a good indication that our wiring integrity to the module and the module itself are probably okay. Most likely this is going to be an issue with the sensor itself. So what we are going to do is connect our leads up to the sensor. I'm using a special little long probe that's insulated so that I don't cross my leads up and get a false negative reading. We're going to go to a graphing multimeter here, volts AC. You want volts AC. This is actually going to put out an AC voltage. We want to be on our lowest scale because we're not going to be turning this very fast by hand. And 1 second scale is pretty good. And I don't feel like putting the wheel back on to spin this thing since I'm pretty sure I'm going to be back in here again anyway. So I'm just putting a lug nut over the rotor, a little hand ratchet. We're going to turn this by hand as fast as we can. Absolutely as fast as we can. And we see we don't really get any reading from that at all. So either this wheel speed sensor is bad, or we have some issue with the reluctor. There could also be a problem with the air gap filled with some metal particles or debris or whatever. So I'm going to take apart and inspect the wheel speed sensor, and if I find nothing wrong, we're going to replace the sensor. All right, sensor's been replaced with a new one. We're going to redo our connections onto the connector to the sensor itself in the wheel, and let's see what we get. And if we turn as fast as we can, we now see we're getting some activity from that sensor, the new one, confirming that this is going to be a fix. So let's get that wheel on. Connect back up with the Autel MS909 and confirm we now get signal from the wheel speed sensor. So now we're going to go ahead and spin that right wheel, and you see we now get signal from it. And also you see, because it's connected with the front left as well, we're seeing signal from the front left. The fact that we didn't see front right the first time was actually in itself indication we had a problem on that right side. All right, that is a fix. Thank you for watching. Hope you found this helpful. Hey, it's Matt from the Schrodinger's Box Do-It-Yourself Automotive YouTube channel with another Autel Accufix Quick Fix. Today we have a 2015 Kia Soul with the very common P0455 evap large leak detected. Everybody thinks the same thing with this code, of course, loose gas cap or bad gas cap gasket. And we usually just tell them, hey, replace the gas cap, and if that doesn't fix it, well, then we got some work to do. Well, we want to do a lot better than that. I don't want to send a person to buy a gas cap on a guess. Turns out that's not where the leak is, and then they have to come back, and I kind of look like a parts changer. So what we want to do is know for sure, is the gas cap the problem? Now, we could smoke test the vehicle and see if we get leakage past the gas cap, but there's a much quicker, easier way to do it using your bidirectional Autel scan tool. All right, we're going to start by opening the filler neck cover, but we are not going to touch the filler cap yet. We absolutely do not want to do anything to disturb the conditions, because if it is just a loose filler cap, we want to be able to catch that. So don't touch anything and just go right to your Autel scan tool. Okay, we need the engine running for this particular test. And what we're going to do is navigate over to Engine under the control unit and Special Function. We see we have evap leakage test. We're going to push that. And it gives you some conditions that are required in instructions. You see that we need to have the engine running and in idle and battery voltage, things like that. We're meeting all of these criteria. We're going to hit OK. It's going to run the evap leakage test. And this can take a couple of minutes or so, so I'll come back with the result. Okay, we came back with our result. We've got rough leakage detected. That is going to be a large leak. So this could be the gas cap, could be something else, but of course gas cap is most common and easiest to check. Let's do that first. I'm going to turn off the engine. Now we're going to see the gas cap was tightened all the way. So now we're going to loosen the gas cap. Loosened a little bit easy there. We're going to check the gasket. The gasket looks good condition, actually. Very important. We're going to check the filler neck, make sure that's clean. And what we want to do is there's a couple ways we can do this. We can either get a big cork or something, a rubber stopper. We could use an adhesive or anything that would completely seal off the filler neck. I also have a bunch of new gas caps that I can put on for testing purposes. But another trick we're going to try is this. Because this gasket seems to be in pretty good condition, I'm going to put kind of a generous layer of grease around the gasket to see if we can make a difference with sealing it. And if this makes a difference, well then of course the gas cap is the issue. If this doesn't make a difference, well, most likely it's not the gas cap, given the condition of this gasket. But we might want to try a better sealing method or something before condemning that it's another component. But let's see if this works first. All right, that should give a good seal. Let's run our test again. Okay, we got the engine running again. We're going to click OK. Rerun that evap test again. All right, look at that. No leakage detected. Since the only thing we did is alter the gas cap sealing, we know for 100% certain this was a gas cap failure, and we can confidently give the customer a new gas cap and know we won't get a comeback. Hi, this is Matt from the Schrodinger's Box Automotive Do-It-Yourself YouTube channel with another Autel Accufix case study. Here we have a 2003 Honda Accord with a P014102 sensor code. There is our P0141. We can see this is an HO2S2, that'll be sensor 2, or the post-cat sensor. We have a heater circuit malfunction, so this is going to be pretty easy diagnosis, very simple system. You've got constant power to the O2 sensor and through the heater circuit, and then the ground side goes to the PCM where it is ground side switched to turn that heater on or off. So your variables are pretty limited. You're going to have some type of blown fuse, short, some issue on the power side. You can also have any wiring issue like a ground fault. You could have a bad PCM, of course, and it's not closing the circuit on the ground side, or more likely than anything else, you have a bad O2 sensor with a burned out internal heater element. Because it is most likely going to be at the oxygen sensor itself, we're going to start our testing there. Now, we want to be absolutely sure after we do this and clear the check engine light that we fixed it. So we want to get some comparative data. And what we're going to do is the way that this code is set is the PCM actually measures for current through the heater circuit system. And as we can see right now, we have no heater sensor currents. Now, one note, when we fix this, it is essential that we clear the code. This is true on most models. Clearing the code will be necessary because as a safety precaution, normally with this code, the computer is going to just permanently turn off that heater circuit. So resetting that check engine light will turn that back on, and with the new sensor, we should see current through it. All right, on this particular model, the O2 sensor connector actually comes up through the floor pan and underneath the passenger seat. Going to disconnect it. This side here is the pigtail for the actual sensor itself. When you look at the wires, there'll be 4 wires. 2 of them will be a different color. That's going to be for the O2 sensor signaling, that oscillating waveform. But there will be 2 wires. In this case, they're both black. The 2 wires that are the same color are for the heater circuit. So obviously, we should have continuity between those wires. With our DVOM set to continuity, we're going to take the pigtail for the O2 sensor itself. Again, look for the 2 same colored wires and test for continuity there. All right, we can see we have absolutely nothing there. That heater circuit is open. There is no question about it. This oxygen sensor needs to be replaced, but we also want to do one other thing, and we want to be absolutely sure when we replace this oxygen sensor and reset that check engine light that the customer doesn't come back because maybe we have some other problem on the other side of the circuit. So in order to test all the rest of the circuit, what I've done is wired my test light into the PCM side connector and just wired the test light into the heater circuit, and we are going to make sure that the test light lights up. All right, we can see that it does light up. This confirms that everything else works, and all we need to fix this car is the O2 sensor. While the test light is lit, we can see that the heater circuit is on, but we also have approximately 1/4 of an amp of current, which would be expected through a test light. We know when we put this oxygen sensor in that this is going to be fixed, and we should see a full amp of heater circuit current. All right, here we have the O2 sensor replaced. We can see we've got our heater circuit maintaining on, about an amp of current, so we know we are fixed. Hi, this is Matt from Schrodinger's Box YouTube channel with an Autel Accufix case study. This is a 2005 Lexus RX 330. We've got check engine light on. I'm going to go to Diagnostics, Lexus, do a standalone, auto selection, read the VIN. We got a 2005 model year without laser cruise. Okay, all right, we could do the auto scan. You notice my battery's really low, so you don't always have to do the auto scan. We're going to go right to the ECU, so I'm going to do control unit, engine, and ECT. Okay, and trouble codes. We've got a P0430. Obviously, we need to diagnose this, but I can tell you these monitors that are used to determine this code are very accurate. It is like 99.9% chance this car is going to need at least 1 catalytic converter and maybe also the second one. We always want to check the second one as well because it could be failing but just under the threshold to set a check engine light. So what we want to do for this is, let's back out of that. And we could pull our data from live data. Again, I'm going for extreme speed here. So we're going to go to special function. And if we do the air fuel oxygen sensor operation, this will pull up all our AF and O2 sensor data. And there's our data. Now, technically, all we really actually need is the bank 1 sensor 2 and the bank 2 sensor 2. I will explain why at the end of the video. But just to be sure, we're also going to bring up, now again, we got air fuel sensors here, so there's a couple ways we could do this actually. I just need to see that we're getting oscillations with the fuel control. Easier on an oxygen sensor because you've got your 0.1 to 0.9 range. Ranges are much tighter on the air fuel sensor. We could do equivalence ratio. Don't see that on here. What we could just do is the short-term fuel trims. If the air fuel sensors are working, we should see some oscillation there. And that's all we need actually. Okay, let's show the selected there. Okay, we can merge all of those on a single graph, and we are going to start the vehicle. All right, we want to make sure that the engine is completely warmed up when we do this. And I can tell you I do not like what I am seeing already. The engine's only at idle. We want to test this at 2200 RPM as well. I'm going to bring up the RPMs. All right, and let's stop that and let's analyze it. All right, we're going to use the sliding scale to go back a little bit. And yeah, there's a lot of data on here, and we could clean this up by just looking at two at a time, but it's actually pretty simple. I can just look at this, and this car needs 2 catalytic converters. What we're looking at is the short-term trim bank 1 and 2. That's going to be the dark blue line and the dark green line here, and you can see they oscillate. Those oscillations are normal, just like you would see with O2 sensor trace. And that indicates that ahead of the catalytic converter, we've got proper fuel control. There are no variables that would skew our results. And those results are the red line and the lighter green line. And we can see all through the trace here, the red line and the lighter green line oscillate. They should not oscillate. They should be straight lines across the top. And that's because if the catalytic converters are working, they will use oxygen in the catalyst reaction. If they use oxygen, that means we're going to have rich signal coming out, but we do not. We actually have the same signal coming out as what's coming in from the air fuel sensors. So that means that the exhaust that is coming in is exactly as the same as the exhaust coming out. There is no catalytic reaction. The catalysts in both catalytic converters are depleted. This car will need 2 new catalytic converters. This is Matt from the Schrodinger's Box Automotive Do-It-Yourself YouTube channel with another Autel Accufix case study. 05 Mazda Tribute with the V6 engine. It has multiple cylinder misfire. Looking at the codes from our Autel MS909, we can see 1, 2, 4, and 5 primary or secondary circuits. So what I'm going to do is go to a known good cylinder. That'll be number 6 here because we didn't have a code. So we're going to take a grounded test light and I'm going to crank the engine over, see if we have spark. All right, we can see we do have spark. All right, we are going to go over to number 4, which has the code on it. And there is no spark. So now I'm going to take my coil from number 6, which we know had spark. We're going to put it into number 4. And we do not have spark. All right, that is definitely a problem. What I want to do is take that ignition coil from number 4 and put it on to number 6 and see if we get spark now. Yeah, we do not. Battery's getting a little weak. But there was no spark there. All right, we may have a problem. We got a shorted ignition coil, and we do not seem to have control from the PCM here. All right, we want to check for ignition control from the PCM. The first thing I want to do, though, is use my Autel MS909 to clear the fault codes, just in case the fault codes are causing the PCM to disable any injectors or coils. All right, we're going to put my number 6 coil back into number 6 where I know we've got spark. Test light into the ground side for the coil. All right, we can see we've got ground side control as we expect. Now let's try that over on number 4. Yeah, we have a definite problem. There is no ground side switching. All right, let's use my LED test light, and there's our problem right there. We're permanently grounded on that ground side control. This better be an issue where we've got a wiring ground fault on the chassis, or otherwise we're going to need a PCM. All right, we've got our test light on our ground side. I'm just going to disconnect the coils and fuel injectors for the PCM, and that's a problem. The light goes out when we disconnect the PCM. That transistor is fried in a permanently closed position. All right, I am always extremely skeptical if we've got a bad PCM. There is no question about it here, but I just want to take one more step. I want to go over to our PCM control for number 6. See our control? And now we're going to go into number 4. Just that right there. The fact the light lights up, that confirms we are in big trouble. We will not get control side switching on this. No control. All right, now we also had codes on a number of other cylinders, not the least of which was number 1. Number 1 is going to be right here. And we do not have it shorted closed. Let's just see if we get control on that. Yeah, we do not. So that transistor is actually stuck open. We need to replace all the spark plugs, all 6 coils, and the PCM. Replacing the coils because if we have any other shorted coils, we would blow the PCM rather quickly with the new PCM. Replacing the spark plugs because it's likely there's an issue with high resistance or too much gap in the spark plugs causing the coils to fail.